161, 162. Intel struggled to shrink their process node from 14 nm to 10 nm, with first microarchitecture under that node, Cannon Lake. Marketed as 8th generation core, only being released in small quantities in 2018. 98, 99. In 2019, Intel released the 10th generation of core processors, codenamed Amber Lake, Comet Lake and Ice Lake. Ice Lake, based on the Sunny Cove microarchitecture, was produced on the 10 nm processor and was limited to low-power mobile processors. Both Amber Lake and Comet Lake were based on Rfined 14 nm node, with the latter being used for desktop and high-performance mobile products and the former used for low-power mobile products. In September 2020, 11th generation core mobile processors, codenamed Tiger Lake, were launched. 163. Tiger Lake is based on the Willow Cove microarchitecture and a refined 10 nm node. 164. Intel later released 11th generation core desktop processors, codenamed Rocket Lake, fabricated using Intel S14nm process and based on the Cypress Cove microarchitecture. 165. On the 30th of March, 2021. 166. It replaced Comet Lake desktop processors. All 11th generation core processors feature new integrated graphics based on the Intel Xe microarchitecture. 167. Both desktop and mobile products were unified under a single process node with the release of 12th generation Intel core processors, codenamed Alder Lake, in late 2021. 168, 169. This generation will be fabricated using Intel's 7nm process, called Intel 7, for both desktop and mobile processors, and is based on a hybrid architecture utilizing high-performance Golden Cove cores and high-efficiency Gracemont, Atom, cores. 168, Meltdown, Spectre, and other security vulnerabilities. In early January 2018, it was reported that all Intel processors made since 1995, 170, 112, besides Intel Itanium and pre-2013 Intel Atom, have been subject to two security flaws dubbed Meltdown and Spectre. 171, 111. The impact on performance resulting from software patches is workload dependent. Several procedures to help protect home computers and related devices from the Spectre and Meltdown security vulnerabilities have been published. 172, 173, 174, 175. Spectre patches have been reported to significantly slow down performance, especially on older computers, on the newer 8th generation core platforms. Benchmark performance drops of 2-14% have been measured. 121. Meltdown patches may also produce performance loss. 122, 123, 124. It is believed that hundreds of millions of systems could be affected with these flaws. 112, 176. On the 15th of March, 2018, Intel reported that it will redesign its CPUs. Performance losses to be determined. To protect against the Spectre security vulnerability, and expects to release the newly redesigned processors later in 2018. 119, 120. On the 3rd of May, 2018, 8 additional Spectre-class flaws were reported. Intel reported that they are preparing new patches to mitigate these flaws. 177. On the 14th of August, 2018, Intel disclosed 3 additional chip flaws referred to as L1 terminal fault, L1TF. They reported that previously released microcode updates, along with new pre-release microcode updates can be used to mitigate these flaws. 178, 179. On the 18th of January, 2019, Intel disclosed 3 new vulnerabilities affecting all Intel CPUs, named Fallout, Rydal, and Zombieload, allowing a program to read information recently written, read data in the line fill buffers and load ports, and leak information from other processes and virtual machines. 180, 181, 182. Coffee Lac series CPUs are even more vulnerable, due to hardware mitigations for Spectre. On the 5th of March, 2020, computer security experts reported another Intel chip security flaw, besides the Meltdown and Spectre flaws, with the systematic name CVE 2019-0090, or Intel CSME bug. 115. This newly found flaw is not fixable with a firmware update, and affects nearly all Intel chips released in the past 5 years. 116, 117, 118. Use of Intel products by Apple Incorporated, 2005, 2019. On the 6th of June, 2005, Steve Jobs, then CEO of Apple, announced that Apple would be transitioning the Macintosh from its long-favored PowerPC architecture to the Intel x86 architecture because the future PowerPC roadmap was unable to satisfy Apple's needs. 61, 183. This was seen as a win for Intel. 62. Although an analyst called the move risky and foolish, as Intel's current offerings at the time were considered to be behind those of AMD and IBM. 63. The first Mac computers containing Intel CPUs. Re-announced on the 10th of January, 2006, and Apple had its entire line of consumer Macs running on Intel processors by early August 2006. The Apple Xserve server was updated to Intel Xeon processors from November 2006 and was offered in a configuration similar to Apple's Mac Pro. 184. Despite Apple's use of Intel products, relations between the two companies were strained at times. 185. Rumors of Apple switching from Intel processors to their own designs began circulating as early as 2011. 186. On the 22nd of June, 2020, during Apple's annual WWDC, Tim Cook, Apple's CEO, announced that it would be transitioning the company's entire Mac line from Intel CPUs to custom Apple-designed processors based on the ARM architecture over the course of the next 2 years. In the short term, this transition was estimated to have minimal effects on Intel, as Apple only accounted for 2% to 4% of its revenue. However, Apple's shift to its own chips might prompt other PC manufacturers to reassess their reliance on Intel and the x86 architecture. 128, 129. By November 2020, Apple unveiled the M1, its processor custom designed for the Mac. 187, 188, 189, 190, solid-state drives, SSD. In 2008, Intel began shipping mainstream solid-state drives, SSDs, with up to 160 GB storage capacities. 191. As with their CPUs, Intel develops SSD chips using ever smaller nanometer processes. These SSDs make use of industry standards such as NAND flash, 192, MSATA, 193, PCIe, and NVMe. In 2017, Intel introduced SSDs based on 3D XPoint technology under the Optane brand name. 194. An Intel MSATA SSD in 2021, SK Hynix acquired most of Intel's NAND memory business, 195, for $7 billion, with a remaining transaction worth $2 billion expected in 2025. 196. Intel also discontinued its consumer Optane products in 2021. 197. In July 2022, Intel disclosed in its Q2 earnings report that it would cease future product development within its Optane business, which in turn effectively discontinued the development of 3DX Point as a whole. 198. Supercomputers. The Intel Scientific Computers division was founded in 1984 by Justin Ratner to design and produce parallel computers based on Intel microprocessors connected in hypercube internetwork topology. 199. In 1992, the name was changed to the Intel Supercomputing Systems division, and development of the iWarp architecture was also subsumed. 200. The division designed several supercomputer systems, including the Intel IPSC/1, IPSC/2, IPSC/860, Paragon and ASIRED. In November 2014, Intel stated that it was planning to use optical fibers to improve networking within supercomputers. 201. Fog computing. On the 19th of November 2015, Intel, alongside ARM, Dell, Cisco Systems, Microsoft, and Princeton University founded the Open Fog Consortium to promote interests and development in fog computing. 202. Intel's chief strategist for the IoT Strategy and Technology Office, Jeff Fedders, became the consortium's first president. 203. Self-driving cars. Intel is one of the biggest stakeholders in the self-driving car industry, having joined the race in mid-2017. 204. After joining forces with Mobily. 205. The company is also one of the first in the sector to search consumer acceptance, after an AAA report quoted a 78% known acceptance rate of the technology in the US. 206. Safety levels of autonomous driving technology. The thought of abandoning control to a machine, and psychological comfort of passengers in such situations were the major discussion topics initially. The commuters also stated that they did not want to see everything the car was doing. This was primarily referral to the auto steering wheel with no one sitting in the driving seat. Intel also learned that voice control regulator is vital, and the interface between the humans and machine eases the discomfort condition, and brings some sense of control back. 207. It is important to mention that Intel included only 10 people in the study, which makes the study less credible. 206. In a video posted on YouTube. 208. Intel accepted this fact and called for further testing. Programmable devices. Intel formed a new business unit called the Programmable Solutions Group, PSG, on completion of its Ultra acquisition. 209. Intel has since sold Stratix, Aria, and Cyclone FPGAs. In 2019, Intel released Agilex FPGAs, chips aimed at data centers, 5G applications, and other uses. 210. In October 2023, Intel announced it would be spinning off PSG into a separate company at the start of 2024, while maintaining majority ownership. 211. Competition, antitrust and espionage. By the end of the 1990s, microprocessor performance had outstripped software demand for that CPU power. Aside from high-end server systems and software, whose demand dropped with the end of the dot-com bubble. 212. Consumer systems ran effectively on increasingly low-cost systems after 2000. Intel's strategy was to develop processors with better performance in a short time, from the appearance of phone to the other, as seen with the appearance of the Pentium 2 in May 1997, the Pentium 3 in February 1999, and the Pentium 4 in the fall of 2000, making the strategy ineffective since the consumer did not see the innovation as essential. 213, and leaving an opportunity for rapid gains by competitors, notably AMD. This, in turn, lowered the profitability of the processor line and ended an era of unprecedented dominance of the PC hardware by Intel. Intel's dominance in the x86 microprocessor market led to numerous charges of antitrust violations over the years, including FTC investigations in both the late 1980s and in 1999, and civil actions such as the 1997 suit by Digital Equipment Corporation. December, and a patent suit by Intergraph. Intel's market dominance. At home time it controlled over 85% of the market for 32-bit x86 microprocessors, combined with Intel's own hardball legal tactics, such as its infamous 338 patent suit versus PC manufacturers. 214, made it an attractive target for litigation, culminating in Intel agreeing to pay AMD $1.25 billion and grant them a perpetual patent cross-license in 2009, as well as several antitrust judgments in Europe, Korea, and Japan. 215, a case of industrial espionage arose in 1995 that involved both Intel and AMD. Bill Gates, an Argentine formerly employed both at AMD and at Intel's Arizona plant, was arrested for attempting in 1993 to sell VIA 486 and 5P Pentium designs to AMD and to certain foreign powers. 216. Gates videotaped data from his computer screen at Intel and mailed it to AMD, which immediately alerted Intel and authorities, resulting in Gates' arrest. Gates was convicted and sentenced to 33 months in prison in June 1996. 217, 218, Corporate Affairs. Leadership and Corporate Structure. Paulo Teleni, Craig Barrett and Sean Maloney in 2006. Robert Noyce was Intel's CEO at its founding in 1968, followed by co-founder Gordon Moore in 1975. Andy Grove became the company's president in 1979 and added the CEO title in 1987 when Moore became chairman. In 1998, Grove succeeded Moore as chairman, and Craig Barrett, already company president, took over. On the 18th of May, 2005, Barrett handed the reins of the company over to Paulo Teleni, who had been the company president, and who was responsible for Intel's design win in the original IBM PC. The board of directors elected Teleni as president and CEO, and Barrett replaced Grove as chairman of the board. Grove stepped down as chairman but is retained as a special advisor. In May 2009, Barrett stepped down as chairman of the board and was succeeded by James Shaw. In May 2012, Intel Vice Chairman Andy Bryant, who had held the posts of CFO, 1994, and Chief Administrative Officer, 2007, at Intel, succeeded Shaw as Executive Chairman. 219, in November 2012, President and CEO Paulo Teleni announced that he would step down in May 2013 at the age of 62, 3 years before the company's mandatory retirement age. During a 6-month transition period, Intel's board of directors commenced a search process for the next CEO, in which it considered both internal managers and external candidates such as Sanjay Jha and Patrick Gelsinger. 220, financial assaults revealed that, under Teleni, Intel's revenue increased by 55.8%, US $34.2 to $53.3 billion, while its net income increased by 46.7%, US $7.5 billion to $11 billion. 221. proving that his illegal business practices were more profitable than the fines levied against the company as punishment for employing them. On the 2nd of May, 2013,